Welcome to a lesson with Dr. Powell. Let's look at some operations that we can perform on matrices. Let's suppose that we have 2 times a matrix. This means we're multiplying 2 to all the entries in the matrix. Imagine that these are expressions. This is an expression matrix like x plus 2y or 3x plus 4y. We're just multiplying 2 to the expressions. So we could think we get, so x plus 2y becomes 2x plus 4y. And 3x plus 4y becomes 6x plus 8y. We just multiplied it by 2. Similarly, over here, we could multiply everything by 3 to have 3, 0, 3, minus 3. See the subtraction? It's as if we're taking this top expression and subtracting this top expression, this bottom expression minus that bottom expression. And like terms combine only. So naturally, this 2 and this 3 would work together, 2x and minus the 3x, to give you a negative x for the top expression combined. And then the 4 minus 0 would just be 4. So we don't write down negative x though. We just simply write down the coefficient. 2 minus 3 would be a minus 1. 4 minus 0 would just be 4. 6 minus 3 would be 3. And 8 minus a negative 3 would be 8 plus 3, which would be 11. Therefore, we would have negative 1, 4, 3, 11. And it worked because corresponding, because there's always something, we always knew what to subtract from what, because we had an expression here and an expression here, and we had the like terms in the subtraction where we could work from. In other words, the size of this matrix was the exact same size as this matrix when we worked it out. So for every expression, we have another expression over here to subtract. For every variable, meaning kind of what we have in the columns, we have those variables over here. Hence, it's a well-defined operation to subtract or add. It's just like we're adding and subtracting expressions, but we're just doing many expressions at the same time. That's pretty much it. What about this? We can have these two. This is just another example. We can have this matrix plus this one. This is the same as adding one expression to another expression. So this is like x plus 2y plus 3z, I think. And we're simply adding 4x plus 5y plus 0z. And so the x and 4x will become a 5. The 2y and the 5y become a 7. And the 3z and the 0 become a 3z. So essentially what we're doing is you're just saying 1 plus 4 is 5, 2 plus 5 is 7, 3 plus 0 is 3. Adding and subtracting and multiplying by a number are very straightforward for matrices and exactly what we expect. The difference is the thing that we call matrix multiplication between two matrices. It's not really exactly like multiplication. It's more like an input operation, but we just call it matrix multiplication. Matrix multiplication probably would be better off if we used this notation for composition, like an open circle. Okay, but these are exactly as you would expect. Now here, does this work? Let's think. You have an expression. You have there's only one expression, but you have a second expression. What does we add it to? We have different sizes. This is a 2 rows by 1 column. This is a 1 row by 2 columns. Different sizes cannot add. So adding and subtracting matrices only works when the sizes are the exact same. Notice how this is different from the multiplication or the input operation that we've discussed already for matrices. Thanks for watching.